Tara Dunn, Vice President of Marketing and Business Development for Averatek, and I am excited to be announcing the A-SAP Community of Interest Resource Platform. The ability to form 15-micron feature sizes with Averatek's A-SAP technology is proven. Now we're building a community of experts who understand how to best apply this benefit to PCB design, optimize the advantage of these tight feature sizes, and reset the technology curve. This technology involves the full supply chain, and together we're creating a platform of knowledge spanning materials, design, fabrication, and assembly, and I invite you to visit often and reach out with your questions and ideas. Let's begin with an introduction to Averatek's A-SAP process and thoughts from across the industry. So what is A-SAP? Averatek's semi-additive PCB process is currently being licensed to PCB fabricators, enabling them to provide feature sizes as small as 15 microns, leapfrogging beyond other processes and changing the way we look at PCB design. While this process integrates easily with traditional PCB fabrication and processing, where this really shines is with its significant impact to space, weight, and packaging, improved RF performance, and as an enabler to simplify PCB design, potentially an overall reduction in size, fewer required layers, a reduction in lamination cycles, and less dependence on stacked and staggered microvias, just to name a few. There's a lot of interest and excitement in the industry for this new manufacturing technology, so let's hear from industry experts in their own words.
The benefit of Averatek's A-SAP process is huge. The design world will need to be ready to have their small-scale design challenges rocked, because the benefit of additive processing over print and etch means that conductive structures can be grown at a scale that's smaller yet taller, which really helps out floor planning while maintaining conductive cross-sectional area. Additive A-SAP process allows for different metal materials to be used, such as gold. Designers need to think of the potentials that different metals within a PCB structure could benefit their design.
One of the things I found with smaller pin pitches on components, it's getting more and more difficult to run the signals between the pins for breakout. We're constantly having to create different via structures and add multiple layers to facilitate an effective breakout. The A-SAP process can really help to alleviate this issue by giving us smaller traces that still have reliable signal integrity.
We're considering the Averatek technology because our ICs have gotten down to the pitch of under 150 microns. We're going down to 135, down to 120, and then down to 100 micron pitch. And we just need something that is going to break the physics barrier right now. About as far down as we can get with subtractive technology is a 2.5 mil trace in space. And in order to break out of these fine pitch devices, we're going to need to go down to 25 micron trace in space or even below that. So that's why we're considering Averatek. We're going to need that to break through the physics barrier and get us into the next decade.
Calumet Electronics, located in Calumet, Michigan, is the first printed circuit board company to commercialize the Averatek advanced semi-additive process. The use of this innovative and transformative manufacturing method requires a new approach to design with manufacturing instead of for manufacturing. Together, the designer and manufacturer can develop a collaborative approach to drop the swap, the size, weight, and power, while increasing the reliability and robustness of the most essential component, the PCB, for next-generation electronic systems.
I'm Brad Bourne, President and CEO of FTG Corporation. We look forward to working with Averatek and their advanced technology for semi-additive circuit board manufacturing technologies to bring added value to our customers in the aerospace and defense market in the coming years.
American Standard Circuits, we are very excited to be an A-SAP licensee. Its two key capabilities are to be able to achieve less than 2 mil lines and 2 mil spaces, and also to be able to build circuits without any copper in it. This is especially beneficial for medical implantable devices.
To really give you a little bit of background, I've been in fabrication about 30 years. Where we see it from an RF perspective is this basically helps fabricators remove the edge tolerance that they have to apply using subtractive processing. So really they can go pretty close to one-to-one. The other advantage is if they can go to smaller lines and spaces and smaller feature sizes, we can reduce these 26, 30 layer designs down to maybe 20 layers, 18 layers, which is also going to reduce cost and improve yields as we're going forward. There's many advantages in different areas for different industries using these types of technology.
In PCB technology, there's always a moving target with HDI. There's a desire to get more circuitry in less space. So with A-SAP, what you can do is you can make the trace actually taller than it is wide, or at least the same height as it is wide, which you can't do with thicker foils. It's just impossible. Making the trace in that shape, you can make the dielectrics thinner and still meet impedance. That's because you're making the trace narrower. But because the trace is taller, you get some of the benefits of signal integrity, and you can also make the via shallower. And now you can go to a 2 mil thick dielectric and still meet your impedance in a strip line construction.
Hi, this is Judy Warner. I'm the Director of Community and Industry Engagement here at Altium. We're excited to see what Averatek and the A-SAP process is going to open up for PCB design engineers with their 15 to 25 micron ability for features. It's going to open up abilities for increased density, for lowering costs. For military folks, size, weight, and power are going to be greatly improved through this technology. And we look forward to being part of this community of interest.
There is a wealth of knowledge in this group of industry experts, and we invite you to join us as we sit down for discussion spanning topics from materials characterization and signal integrity analysis to PCB design and fabrication best practices. Please subscribe to our YouTube channel. Visit our website at www.averatek.com, where you'll find links to this information. Sign up for our email list to be notified as we release new content. Or always feel free to contact me directly to learn more about A-SAP technology and how to best optimize this for your design requirements.